We will create the following 3D model using SolidWorks. Basically, what we have right here is, bear with me, is this shape, just this one. It's rotated along this direction. There is one triangle here at the middle with its respective depth, and there is a corner right here. That is pretty much it. We're going to start creating the sketch of the lateral view, and extrude. After that, we will create this pyramid or triangle, and later we will do the packet. All right. As always, we're going to take into consideration the information within the engineering draw. First, we need the unit system. Second, we need the dimensions. For the first inquiry, the person who made this engineering draw, Luis Miguel Huerfano Garzón, didn't place the unit system. This is not mandatory, guys, because if you don't find that information, you can assume that you are working in millimeters. Second, there is some things that I want to mention about the engineering drawing regarding the normativity, how to place some different dimensions, things, proportions. But if you want to hear this, I'm going to talk about this at the end of the video. Right now, we're going to focus on how to work using SolidWorks, right? So we're going to start by clicking on the arrow, new part, okay. Alrighty, we're going to click on a sketch since we're already in here. So a sketch once again. I'm going to select the right plane as I mentioned before. I want to create like an L shape, so it looks something like this. I don't really care about the dimensions, guys. Please be aware that when you're working with SolidWorks uses a feature in which, for example, this dimension is 107.51. This dimension is 95.18. If I change this to 5000, for example, what SolidWorks does is that, taking into account the proportions of the sketch, that is going to take into account for an equivalence. So for example, 5000, and now this is not 90 something, it is 4426.61. So that is why I didn't care about the dimensions just yet, guys. We just care about the proportions, right? So once again, smart dimensions. This is 34 millimeters. This is 36. This is 12. And this is 14. All right. Okay. Features extruded. I'm going to extrude at 55 millimeters. Okay. After that, I want to create a reference geometry plane. We're going to take into consideration this face and let me allow the rotation. These others. So when you select both, SolidWorks automatically generates a exact middle plane between the two faces that you have selected. All right, it looks good. Now I'm going to create a sketch taking into account this plane. Let me see, sketch once again, plane, right? Control 8 for me to be working in a perpendicular way. I'm going to disable the rotation. And basically, I just have to create the triangle. All right, escape. This point and this edge should be coincident. Now for this dimension, this is let me see, 34 minus 12, which is the same thing as having, sorry, this dimension is not necessary. Right, so selecting both of the points, I'm able to create a coincident point, sorry. And now enable the rotation. I'm going to features, extruded both base. This is 15 millimeters, so 15. Mid plane. Right, okay, and now what's left is to create the pocket. So sketch once again, right here, Control 8. Rotation off. Basically, I just have to create another triangle, sorry, right here, and right here. And from here till here, there is a 43 millimeters dimension. Okay, now features, extruded cut, rotation none, through all. Okay. Alright guys, this is how you can create this 3D model using SolidWorks. That is pretty much it. Of course, I'm going to hide this plane, and that would be all, guys. Now, regarding the engineering draw, there is some things that I will always mention, take into account that I'm like uploading a lot of videos and I'm always using the engineering draws from actually from the ones that Luis Miguel Huerfano Garzón did. Why is that? Because I consider that he has made some different errors and I want to show you which ones and how to solve those, right? First one, for when you're taking into account the normativity of an engineering draw, there's always a box that usually goes right here. Usually. Within that box, you place, for example, the unit system, the name of the person who made this engineering draw, the name of the part, if there is some tolerances information, some manufacture process, some notes, whatever. The material, of course. He always places the material right here, so I know that this was meant to be, I don't know, aluminum, copper, steel, but please place that information on that box. Now, regarding this nomenclature, guys, please Google it. ISO A, ISO E. This is referring to the views, either if the front view it's this one or if it's this one. All right, this is pretty important because this nomenclature is going to tell me which view is which one. You just have to Google it, Google images, and you will understand what I'm talking about. Now, the proportion, guys. There is a lot of space right here for he to place this isometric view right here. Alright, for the rest, this is a pretty basic shape, this is a pretty basic part, so it is not necessary for me to mention anything else. Once again, guys, this is how you can create this 3D model using SolidWorks.